Well, hello everybody. My name is Malcolm Sparks and I'm from Juxt, from the UK. There's two of us over this year, John and myself, and we're very, very happy. It's our first time in Finland, first time to the conference, and we're really happy to be here and also happy to be one of the sponsors. I'm going to talk about a project I've got called Yada. Has anyone heard of a project called Biddy that I wrote that was about routing? So a few of you. Yada is really like a sequel to Biddy. I've been working on it for a long time. If you want the slides, that's where to get them from. So I'm here to talk about HTTP. And we all know that HTTP is a big and complex specification. If we added up all the RFCs, it's a very big set of specifications. And you may recognize some of these words here, although perhaps not all of you know all of them. But why is HTTP so big and so complex? Well, it boils down to two things. First one is we want our services to scale. We don't want them to go down when the services are busy. The second one is that often we want our services to last a long period of time. If you put a REST service up and some applications start using your API, then you've got to keep that service up for as long as those applications survive, as long as the last person who uses those applications has stopped using it. So longevity in HTTP services is measured in decades. Okay, so when people, and don't listen to the JavaScript folks who talk about things like REST being dead and stuff, because I think longevity in JavaScript, as Marcus alluded to, is measured in days and weeks. These services have to last. Now, HTTP services in Clojure, it's about Ring, right? We all use Ring. How do we feel about Ring? It's great. We love Ring. Ring is fantastic. We get requests and we get responses, and this is just data. We love Ring because Ring loves data. How do we feel about Ring middleware? Yeah, I started asking myself, is Ring middleware suitable for building HTTP services? Who's used Ring middleware for their applications here? Keep your hands up. I put this slide in because Misha said that's what you've got to do, but I realize now I've got a bit of explaining to do. So I'm going to give three quick examples. This is a method in HTTP called head. I will just remind you what it's for. It's for going to a resource and getting just the headers because you don't want to get all the body for whatever reason. So let's see Ring's implementation of head. So here we have the head request, and we say, OK, if it's a head request, we'll actually pretend that it's a GET request. And then we'll process the GET request, and then we'll get the whole payload back. And then in the response, we'll take the body and we'll turn it to nil. Can anyone see anything that's remotely suboptimal about that approach? No? Well, let's try Compojure. Now, Compojure, we love Compojure. Imagine you have two routes here, /hello, and you've got a get and a post. So the question I want to ask everybody is, which HTTP status do we get if we send a put to hello? Does anyone know this? Well, actually, it doesn't match either, so it becomes nil, and usually that means a 404. You'll get a 404. But for the HTTP nerds in the audience, which HTTP status should we get? Anyone? A 405. If you said 405, then give yourself a clap, because that's the right answer. So 405 means it's not a 404, because hello does exist, but it's a 405 to say there's no such method. Okay? But the problem is the modularity of Compojure causes a problem, because routes doesn't know anything about the nature of get and post. So how can Compojure know to send a 405 rather than a 404? It can't. My last example is wrap modified. Now, let's again remind ourselves what wrap modified is for. It's in order to compare dates. So we've got information, we know what the state is last Tuesday, and we want to go back to the service and says, well, I've got last Tuesday's numbers. Has there been any changes since last Tuesday? Do I need to get a new copy of the version? And let's see how Ring implements this. Okay, so we have wrap modified. So what's going on here? Hang on. So we're processing the request first, and then when we get the whole response back, we then look at the headers. Well, I don't think that's really in the spirit of what we're trying to do in HTTP. So there's a bit of a smoke and mirrors thing going on with functions. But is it Ring middleware's fault? Well, I don't think so, because Ring middleware here, this middleware has only got this handler to go on. What's that handler? It's a function. What do we know about that function? Do we know how many arguments it's got? Well, we can try it with one, and we'll get a boom, arity exception. Can we try it with, can we print it out on the repo and get Java class gobbledygook? We can't find anything about that. And it reminds me of a scene in Hitchhiker's Guide to the Galaxy where Arthur Dent and Ford Prefect find themselves transported onto a spaceship. And Arthur is curious about the dashboard and says, what happens if I press this button? And he presses it, and a sign lights up telling him not to press the button again. This is the same for Ring middleware. What would happen if we try and call the handle function? We don't know until we call it. It's not a great way of building information systems. And there's another problem with Ring middleware, and that it's a pick and mix approach. We pick the bits of HTTP that we want to implement, or rather, if we're honest, have time to implement, and ignore the rest. And it's debatable whether it's even possible to implement a complete HTTP service in Ring. So is there an alternative? Well, I believe that to find the answer to that, we need to go back to see what we love about Ring, which is to follow the data. So that's why I started experimenting and building what ended up being Yada. And it was also influenced by my experiences of building web services, particularly with Liberator on a number of projects, and also from talking to a lot of people too. So it's my ambitious, or rather naive, attempt to implement all of HTTP, or at least the bits beyond what you get from HTTP servers like Aleph. But it sounds a bit crazy. It probably has been a bit crazy, but I'm in too deep now. I just have to carry on. So it's too late. But actually, Yada is easy. It sounds like it would be complicated, but Yada is just a function that takes that returns a Ring handler. That's all it is. So let me give you an example. This is Yada hello world, and the result you get is, well, it's a map. And it's data. Hooray, we've got data back. And this is showing us up here. If we look up here, we've got 3 methods. Why have we got 3 methods? Well, what do we know about Java strings? We know that, hang on, I'll just try it. What do we know about Java strings? Well, we know that they're immutable, right? So we know that we can't change them. So that discounts put, post, and delete straight away. And we also know, because they're immutable, we know the last time that they can possibly have changed. So we already know the last modified date of that string. So we can use this information to derive quite a lot of data. So we know that immutable strings in Java can't take put. But what about if it was mutable? What then? And Yada will then return some data to say, I've got some. Yeah. And here we've got put, post, and delete there. We can also use a function, our friend the function, but because the function isn't very sociable, we can add extra information in a second parameter, which I call the option argument. So Yada is a function that usually takes 1 argument, but it can take an optional option map. This actual presentation is being powered by Yada now, and this is the code, if you can see that. I tend to like to run my talks on bleeding edge tech because I'm stupid. But there's a whole load of other things that you can make Yada handlers out of. So Clojure collections, vectors, sequences, and you can even create your own types. And because what Yada actually produces is a map, it is data, that itself you can turn that into a ring handler to view that. And that ring handler itself is data, so that could, and you get the idea. Features, parameter coercions. So here we've got an example of having, we do it on a method by method basis. So here is a get and a post, but you can have any method. You can have paths, so this would be extracted from a biddy path variable or a query string. You can have headers, forms, bodies, cookies, and so on. If any of these values is invalid in the request, we get a 400 straight away, boom. But also we get there's quite powerful coercions, prismatic coercions in Yada, so you get the values in the types that you want them. Content negotiation, media types, char sets, encodings, and languages. Just an example, it might be that you want to serve English and Finnish text in UTF-8, but you happen to have some old Chinese translation in a compressed file of HTML which happens to be coded with Shift.jis. Now, I know what you're thinking here. You're probably thinking, well, that doesn't sound very useful. And you're right. But when you're implementing a specification, you kind of don't care whether it's useful or not. You just implement it all, and that's what I've done. So you can mix up these, you can mix and match these content encoding axes. Who's written services that had to be JSON because, other languages? Have you written services that you've had to? Have you ever consumed those languages? Have you ever consumed that data in your Clojure script app? Have you ever tried to do that? It's horrible, isn't it, right? Because you don't have keywords. You have to turn the keys into keywords, and then you've got camel case, and it's nasty, and you do kebab, snake stuff, and then it's just horrible. But it would be nice if you could, just by adding a couple of lines to your service, to get Eden for free and support your JSON clients at the same time. And that's what content negotiation allows you to do. Yada has a little secret feature here where we can also get prettified versions of these things. Conditional requests, date matching, e-tags, all that stuff, that's done. Routing, obviously it does play well with biddy. This is the biddy routing structure, and here we've got a hello and a hello resource. So Yada resources are data, and they just become leaves of your routing tree, so you can describe your entire service just in data, which is handy. I saw Tommy's talk in Poland last year about Swagger, and we love Swagger in Juxt. We use it for all sorts of things. We use Compojure API for projects, and the reason we like it, because you can just deliver documentation to the users of your service. So I wanted to get that done. So built-in Swagger. This is what you do. You take a routing structure and you just wrap it in this Yada Swagger with some provided metadata, and then Yada Swagger would do the rest. And if you remember our friend here, the atom, you get the Swagger just like that. So that's in there. Just 2 minutes to go a bit deeper into how this works. It's quite simple. We have that swaggered function takes that information that we gave it and the rest of the route. We can, this is some logic here that goes and creates the Swagger specification. So that's a Clojure map. And then what we do is we create a biddy tree node here, and that's going to go into the biddy tree, and it's going to take the Swagger spec, which is our data, but we're going to Yada it because we want to publish it, and the rest of the route. So let's have a look at this. This is a biddy node. If we match, don't worry if you have never used biddy, but essentially this record will get asked, do you match? And it will say, well, if there's a /swagger.json on the end of the path, then I do match. Otherwise, I'll just delegate to my root structure and keep traversing. And so if we do match, we get to we've got given our spec. That's just a ring handler. So we call the ring handler with our request. And finally, this is our Swagger spec. We're saying, yeah, we have application JSON. We can serve it in UTF-8. JSON also says that it can be UTF-16 or UTF-32, but we would prefer not to provide those if the client accepts UTF-8. And at the same time, what we'll do is we'll call ring Swagger to create the, use the ring Swagger library to create the actual Swagger specification ready to go. So this is a one-line integration with ring Swagger. So you get all of your schema, you get all your prismatic stuff. It's all converted to JSON schema for Swagger for you. And then this is the spec. This gets hashed, and that becomes the version which then drives the formation of the E tag. You don't really have to. That's really how you provide it to Yada. And then finally, we have the get method, and we just send out what we got from ring Swagger. All of the turning into JSON and all the representations in the body and the coercions are all done by the mechanics of Yada, so you don't have to worry about that. Data transformation, well, it's just a tree. So one of the questions is, what if you have a part of your routing tree where you want to add some kind of security policy onto it? Well, I just use a post walk. It's a data structure. I can navigate it, and I can go and change things about the handler. Handlers do have interceptor chains in them, and you can go and mutate those as well if you want to do something funky or add your own logic. So it is just a data transformation at the end of the day, and you can use Clojure core functions to do it. And there's a whole lot more that I haven't got time to talk about. But I do want to mention just one thing, which is about async. Yada is built on a library called Manifold from Zach Tellman, which is super awesome, and I want to explain why. So often, here's an example. Often when you're, let's suppose that our hello world was actually in the greeting.txt, and here we're about to do some I/O, right? So the problem with I don't want to go into why other languages and other frameworks are embracing async, but the problem is we're going to be blocking the request thread now, and then eventually we're going to get an exhaustion of too many request threads blocking on I/O. And so this allows us to simply return a future. So if we're about to do I/O, we can return a future, or a promise, in fact. So there's some libraries like HTTP-Kit that allow you to have a callback for when the response is ready. So what you can do is create a promise, and then give that promise to HTTP-Kit, and then return it straight away. When HTTP-Kit comes back with a response, then that gets delivered, and Yada carries on. So there's no I/O blocking. Here's another example. You can return anything. You can return core async channels if you like. There's a whole lot of things that are considered to be deferred in Manifold. If you want more details, you need to look at the Manifold library, but it's extremely powerful. There was a discussion last night in the sauna about the problem we have in the Clojure community about naming things, right? We name things like component and system and boot, and I don't want to embarrass anyone here, but it's really hard to Google for these things, right? So you're searching for boot, and it comes up with buying shoes and stuff, and you know, that's not what I want. So I then go back and I type Clojure space boot, and then I get to the boot website. So that's a problem. So I thought I'd solve that problem by creating a search engine. What this does is say, well, we want a Q parameter, which we're going to turn into a string. That's a query parameter. And then we get to do our get. We're going to ask Aleph to go off to Google, but this time we're going to take the query and we're going to put Clojure in front of it. Okay, and then we're going to get some decent results back. So that's how that works. However, I wasn't really wanting to explain about parameters. It's really clever here, because what's happening is that the request thread goes to Aleph. Aleph is now returning deferred results. So this returns straight away. And when Google comes back with the answers, then the deferred gets delivered, and it all carries on. So there's no I/O blocking at all in any of this code. It's all done behind the scenes. So it's a really clean example to show how powerful this is. So that's a really, really nice feature of Yada. And it's async everywhere. Instead of, it's not just your interceptors or your methods. Anytime you've got a callback, it might be to determine if the service is available. You can do that in a deferred. So everywhere you want to, and even places where you might not want to, there is the facility to return back futures or promises or channels. Server-sent events are really easy because the whole thing is based on an async foundation. So that's a service center event which is happening every second using a Go loop, and that's all we have to do to create an SSE channel. Documentation is available yada.jux.pro. That's the roadmap. Entered 1.0 beta last August. I think it will take probably until early 2016 to get finished, but it's ready to use now. Perhaps not in production, but definitely worth playing with. And I think by early 2016, we'll get it finished and support it. So lots to do, but thanks very much for listening.